Now let's examine migrating other tables such as group, hosts, services, and protocols from etc. We've migrated users, we've tested SSH connectivity, we've configured PAM, we've confirmed NS switch operations. So let's move forward with moving some other tables that may be useful to be shared between your hosts. Now again, each host that's participating in the LDAP directory information tree sharing maintains a list of tables that are referenced via nsswitch.conf, and they include users, groups, hosts, services, protocols, net groups, and other types of tables. So rather than maintaining individual copies of those tables per host, it's much easier if there is a common denominator amongst them to share them using a protocol such as LDAP. That's the whole purpose behind LDAP. So we'll label this section Migrate Other Tables. And you can choose whatever tables you would like to see in the directory information tree, but for us, we'll focus on etc group initially, followed by hosts, services, and protocols. Now obviously, features include shared records via LDAP DIT, which means we maintain the records in one place as opposed to multiple places. So our first task is to migrate etc group to LDAP DIT. Now if we confirm the existing layout of the tree using LDAP search, we'll see that we have yet to migrate groups. We have migrated users, however. Let's reconnect to the server. The connection tends to terminate after a period of inactivity. That's an SSH setting that can be tweaked, but doesn't impact our environment one bit, other than having to reconnect. We'll execute exclamation LDAP search, which enumerates users. And if we look simply for organizational units, which will tell us whether or not groups have been migrated, we see a list of 6 entries returned. Let's scroll towards the top and read them top down. Base DN is a container. People, engineering, sales, LDAP config, which SUSE set up for sharing the configuration of the SUSE hosts so that we can download it from other hosts, and group. Now let's query the group OU by changing the base search from DC equals Linux CBT DC equals internal, or the base DN to OU equals group, and then a search for any object using the wildcard star. And notice the only thing that was returned was the group name itself, the base container, the organizational unit. So there are no groups migrated. Now groups live in etc group. So let's just scroll down. We will want to use the script, the migrate_group.perl script, to help us migrate this information. So we'll be executing migrate_group.pl, followed by the input file, which is etc group, and this will dump to standard out. So dumps to standard out groups, and we can select which groups should be sent over. Now if we redirect it to a file and then edit it, it makes our task a little easier. But let's go ahead and take a look at this from the master server's perspective. We'll navigate into Paddle, Migration Tools, and the Perl script of interest is migrate_group.pl. So we'll execute it, and there it dumps the various groups to the screen. But we may not necessarily want all groups to be converted, or we may. It depends on the environment. For example, SUSE Enterprise Linux does not maintain a group per user, whereas Red Hat does, and it may not be convenient to translate those groups over. Or it may be, depending on how the permissions are set throughout your file systems. In any event, you can scroll through this list and determine which ones make sense to migrate, or you can migrate them all. Migrating them all is pretty straightforward. We dump this ldiff dump to a file. So we'll send this to groups.susa2.ldiff so that we know what it represents. And then we will use ldap add to import it into the directory into the group organizational unit. So we can update this to include output redirection to groups.susa2.ldiff, followed by ldap add the bind dn, which is cn equals manager, dc equals linux cbt, dc equals internal, simple authentication, prompt for password, the file, that's groups.susa2.ldiff, and any other options that may be applicable. Now, we want to import these items into the organizational unit group. They will be by default because of the way the migrate_group Perl script has prepared the ldiff output. If you notice, for each object, the reference is to OU equals group. So ldap add will process the OU string and import the items into that OU, into the group OU. Let's try to import these items. It'll prompt us for password, which is still ABC123. Now this happens because the default schema which handles the POSIX group object class does not define, and this is specific to SUSE Linux, does not define the object class POSIX group as a structural object, but rather as an auxiliary object. So the reference here is telling us that when creating objects, we must indicate at least one structural or top-level object. So to fix this problem within SUSE Linux, SUSE Enterprise Linux, we need to switch from the RFC, which defines POSIX group as an auxiliary class, to the NIS schema which contains the object group, which defines POSIX group as a structural class. So let's just note, in SUSE Linux, replace RFC schema, it's one file, with NIS schema in slapd.conf. Let's go ahead and try that and then re-import or attempt to re-import the group information. So we'll nano etc open ldap, slapd.conf, and in here we see references to the schemas. So this RFC schema defines the POSIX group as an auxiliary class. This will comment and ensure that we reference the NIS schema, which also has a definition of the object class POSIX group, but defined as a structural object. And before restarting the service LDAP, let's take a look at those items. We'll grep POSIX group, which is what we reference when we try to import, and that's what we see up top here, the reference to POSIX group. So let's grep it case insensitively from star schema, and we see two references. In the RFC 2307 BIS schema, we can take this exact name since it's here. Again, this applies only to SUSE Linux or any distro which includes the RFC schema that we're referencing, so, or that is referenced by default. Let's change this to the exact name. So the reference grep is return the line where the object class POSIX group is defined as an auxiliary class. So it's not a structural class, and objects must reference at least one structural class. However, in the NIS schema, there is no reference to auxiliary, which means it's structural. And if we grep around POSIX group in NIS schema, we'll see clearly that it's of type structural. So now that we've updated slapd.conf, we should restart it, of course, for the changes to take effect. So restart slapd to enable changes, and then return to adding the group objects that we exported using the paddle scripts. So rcldap, restart, and we'll echo the exit status shortly after it starts to be sure that it started correctly, and an exit status of 0 tells us that it has. So with that said, let's return to our old PWD, which is a shell variable, and attempt to LDAP add once more. An exclamation LDAP add should do the trick. And it prompts us. This will import groups.susa2. No changes necessary to the LDIF file. And there we see all of the entries have been added to the directory, which means if we now query the contents of the OU group, we'll see each of the groups that were exported from the SUSE box. And now it becomes a matter of consolidating groups across systems such as Solaris, Red Hat, SUSE, and other distributions to come up with one set of groups that, or a common denominator set, which applies to all. So let's list as step D that we want to confirm that the groups have indeed been created. So confirm the existence of groups using, of course, LDAP search. Let's construct a string. We'll history grep LDAP search. And there we see a recent instance of it. Let's copy it, but we'll drill down to the group organizational unit. So let's fix it up in our text document, changing the base DN to be OU equals group. And this will enumerate all of the objects in the organizational unit group. And there are the objects that were copied over from the primary hosts, SUSE Linux. So these are groups that you'll find throughout SUSE Linux, users, etc. www for the web user. Again, you'd need to navigate in planning your migration across or through your various NIC systems to find those unique groups that need to be migrated into LDAP. You certainly can by pointing the paddle script directly to the etc group file and then sending the output to a file and then parsing only the objects that you want and then importing them using LDAP add. Now another way to confirm that the client is able to see these groups is by using getEnt, as we did previously, but instead of password this time we'll use group. So use getEnt group to confirm LDAP groups. And this we should be able to do from any of the configured systems. We should be able to confirm, for example, the users group, which may be too generic, or the www group, which SUSE tends to use. Others use other group names that are similar. Let's go ahead and getEnt group, and we see a duplicate list of groups returned because the same groups are defined locally in etc group on the SUSE host. So expect the groups to be repeated. There we see @ in the second set, and towards the top @ in the first set, and towards the end users. So the group names are indeed duplicated. Let's confirm over on the other systems. We'll just list as a subset or a substep test on LDAP slaves. So let's try Solaris. Here's our Solaris window. GetEnt password reveals all of the users that are local to the Solaris box, as well as those imported into the LDAP DIT, including the ones we've tested with, SUSE2 local, as well as RH local 1. GetEnt group will behave similarly by listing local groups as well as LDAP-based groups. For example, anywhere you see SUSE should indicate that it comes from the primary LDAP server, which happens to be SUSE Linux. Here's the users now. We can grep some of these items from the local etc group file to be sure that they haven't come over from etc password on the Sunbox, to be sure that indeed they're coming from LDAP. For example, SUSE-NCC. We'll grep SUSE-NCC from etc group. It doesn't exist, so grep returns a non-zero exit status as expected. Let's grep users from etc group. Also doesn't exist. Now there will be times, of course, where duplication will occur, so you need to plan for that. Any migration project will involve a considerable amount of planning, especially for items such as redundancies, redundant users, groups, objects, etc. So this all goes or factors in to proper migration planning. Now with that said, let's move on to another task, which is to migrate the items in etc hosts. Again, this is for simplicity and centralization, which promotes efficiency and a central point of storing your data. Now, we need to ensure that there's a hosts OU in LDAP, and we can use LDAP search from any of the hosts to confirm that. So let's find a recent invocation of LDAP search. And we need to tailor it to enumerate the organizational units. So we'll search from the base, but we'll set object class to organizational unit. So this lists or enumerates the various organizational units. Let's take a look at our list here. We see the base, OU container, people, engineering, sales, LDAP config, which was created by SUSE, and group. Now, the simple way to create the top-level container hosts is to use the migrate base script. So use, from the paddle, open source scripts, of course, migrate base _PL to create various OUs. You can use it in one swoop to create all the top-level OUs that don't exist. For those that already exist, such as group and people, the migrate _base Perl script will ignore those objects and create the others. Let's try it the simple way, which is to execute it and have the script dump the LDIF information to stand it out. We can then copy into memory this information. Notice an OU definition per object type. And if we scroll towards the top, we will see one for hosts. We'll copy this LDIF entry. This is the precise entry. And then we'll paste it into our DIT. So this container uses or references two object classes, top and organizational unit, and its name is simply hosts. Let's go ahead and create this. Obviously, we'll use LDAP add to import. Let's find a recent invocation of LDAP add. And instead of indicating a file, we'll have LDAP add wait for us on standard in. We'll paste it. Control D to indicate that we've ended our paste. And there we see adding new entry hosts to the DIT. Which means if we rerun LDAP search to confirm with a focus on organizational units, we see that we now have a hosts OU. This is our container for migrating information from etc hosts. Now, just like we did with the group file, with the exception of we don't need to change, in this case, any schema files that are imported in slapd.conf to make it work as we did with the group OU. So use the migrate_hosts PL script to import etc hosts entries. And this you can just do on all of your hosts, and if there are duplicates, then the LDAP import process will complain. Let's point this to etc hosts, and you'll see on standard out how the items are formatted. These are the entries placed within. For example, a host such as LinuxCBT Sun1, the Sun box, is given a common name which identifies it uniquely in the DIT of LinuxCBT Sun1.linuxcbt.internal. So an FQDN, in other words. It belongs to the OU hosts, DC LinuxCBT DC equals internal. It also belongs to the object class top, as well as IP host and device, where it inherits various attributes, one of which is the IP host number, which in this case is 192.168.75.150. Now obviously, if you populate your LDAP DIT with etc hosts entries, and those entries change frequently, you'll have to maintain those entries, which is why we spend a separate section simply on maintaining the LDAP DIT by updating the DIT wherever necessary. But usually you'll want to place information in LDAP that doesn't change frequently, which is what we mentioned earlier on. LDAP is more of a read database than a write database, although it certainly supports writes. It's optimized for reads. Now we've yet to import these items. Also notice that the names, the common names, there are two entries per host for common names. One represents the short name, the other represents the FQDN. So you can store multiple values in a given variable. We mentioned that earlier on, that some fields, some attributes support multiple values. In this case, we see CN is one such attribute. To import these items, we should export the contents dumped to standard out to a file, and then import that file. So let's place this in a file. We'll call it hosts.susa2.ldiff. And it's always good to echo the exit status to be sure that what you expected of the utility actually occurred before relying upon that data. Now we have the file, hosts.susa2.ldiff, and it contains the LDIF necessary for import. It even includes a reference to localhost 127.0.0.1. Again, these are all items that will be referenced by the other hosts once we update nsswitch.conf, of course. So next step is, of course, to use LDAP add. And we know that was coming, so let's go ahead and do so. And in fact, LDAP add should be step C, and let migrate hosts be step B. And let's find a recent invocation of LDAP add. And this time we will reference a file. That's hosts.susa2.ldiff. We're prompted for authentication, and if all goes well, the entries will be added into the OU. Now notice it tells us that some entries existed, and let's take a look at what was created by using LDAP search. This dumps the various OUs, and let's this time focus on all of the objects within the OU by changing object class to star and specifically indicating the OU equals hosts. Let's see what was imported. So the LDAP add command failed because a loopback entry already exists. The nature of most LDAP commands is to fail in the event of a problem. But as we've mentioned earlier, there are ways of circumventing, or there is at least one way of circumventing encountered errors. In the case of LDAP add, we want to turn on the -C option. -C will ignore errors when encountered. So in the case of duplicates. So notice LDAP add encountered an error, but it continued operating on the remaining records, importing what we see here, entries for IPv6 through Linux CBT Serv 4, Sun 1, SUSE 2, which means now an LDAP search should behave as expected. But let's just copy the LDAP add command that was successful for us. Very simple command. We just turn on the C option, and then we'll execute LDAP search. There we see the various items in LDAP search. So use LDAP add, and we use this form of it. Note, enable continuous mode, which is basically -C if necessary. And it usually is during migrations, because oftentimes we do things twice. We import the same file twice, so the -C option becomes very handy. Now, to confirm that this all works, let's label step D, and we'll include some space here. Update NS switch configuration, which of course means etc ns switch.conf. And then our next step will be to confirm that the items in the LDAP DIT tree branch hosts are resolvable. Let's modify etc ns switch, and we're looking for hosts, the host section. Here we see hosts currently consult files then DNS. We may optionally turn on LDAP. Now, if you want LDAP to be consulted before DNS, then specify files, then LDAP, then DNS. And the databases will be consulted in the order in which you see them here. Files, LDAP, then DNS. Or if you wanted to test the waters and just try LDAP alone, to force the lookup through LDAP, then DNS for items, then by all means do that. But this isn't the recommended configuration. The recommended configuration is to always consult files, then LDAP. So we'll leave files in, and we'll remove an entry from files to be sure that it resolves. Now, one quick test of whether or not you're able to resolve the entry is by using getEnt. Let's indicate that if we use getEnt instead of hosts, or instead of password groups, we indicate hosts. getEnt will query LDAP as well as any local databases for entries. Let's give this a try. And there we see various items that are resolved from both local etc password as well as from LDAP. Now let's comment out one of the items in etc hosts. We'll comment out Linux CBT Serv 4, and then rerun getEnt hosts, where we see that Linux CBT Serv 4 still shows up. Sun 1 and SUSE 2 show up twice, as well as localhost, because they exist in both etc password, or etc host, that is, hosts, as well as LDAP DIT OU hosts. So the entries come up twice. So this is working. We've been able to move successfully information into the DIT. Now let's go ahead and migrate two other tables. We'll begin with etc services. Process is the same. We need to create a services OU, which migrate base does for us. So create services OU using migrate base.pl. Then use the migrate script to extract the entries from services and then import it using LDAP add. So migrate base dumps what's necessary to the screen. We extract the LDIF for services, and there it is. Let's get this into memory, then execute LDAP add. In this case, it has the recent invocation of F to reference a file, so we'll try it again. And now it's added a services top-level OU. Control D. Let's look through our history of LDAP search attempts, and let's look at the current lay of the organizational units in the DIT using the entry 688. So here are OUs including the recently created services. Now, as mentioned, there's a script for everything, including services. Migrate services. You must specify an input file. etc services dumps the standard out, the various services. If we dump this then to services.susa2.ldif, it creates the appropriate file. It throws Perl-related errors. Let's just make sure that those errors don't exist in the services file, and they don't. And this is a hash-related error, so the script may need a little debugging, but nonetheless, we see that the services have been defined. Their type, object class, CN or DN in this case, distinguished name, etc. Now let's use LDAP add. We'll history grep LDAP add. We'll find an invocation that does not reference a file, such as 699. Well, 699 does, so let's go with 680. Then kill it and get it back into memory, and then reference the file. Services. This prompts us as expected, and then the entries are imported, minus any errors that are reported. If there's an error, like in this case, additional info provided more than once, then this means that there's a duplicate, which is fine. And let's find LDAP search to confirm the entries that have been included. And we'll search all objects in the OU equal to services. And then it dumps the entries. Now, it encountered an error after the 9th record. So if we take a look at the services file, it contains far more than 9 records. So we need to debug the problem at the 9th record, or turn on the -C option to have it skip whatever errors were encountered. And we can also redirect the errors using the LDAP add command. Let's turn on -C. And now this looks more like it. So there's probably just one record where there's a problem. And this is going through all of the supported services now. In TCP and UDP, there are 65,536 ports, 0 through 65,535. Many of the ports are defined, which is why we see so many entries being imported. And again, as mentioned, we can use LDAP add to send errors encountered during the add process to a separate file for further evaluation. Those LDIF entries which failed the import test can be analyzed independently. And this will definitely take some time. So we'll just let this run. And while that runs, let's set up our final task. And that is to migrate etc protocols, which contains a list of protocols that are supported. This list is not as extensive as etc services, so the steps are similar. Create protocols OU using migrate base.pl, and then follow the remaining steps. And this is finally finished. So an LDAP search will return a number of records, 500 entries, and that's more like it. Let's migrate base, and we will find the OU defined for protocols. The LDIF, which represents the OU, will then execute LDAP add, looking for the one which expects records on standard in. and item 680 seems to fit the bill. This will wait for us on standard in, and the OU has been created. An LDAP search, which never hurts, just to be clear that we have what we need before we attempt the import of organizational units such as 712, should tell us what exists in the DIT at the top level. And there's the protocols OU. Now, as mentioned, there's a script for everything. So let's migrate. And that'll be protocols, etc. In this case, the input file in this case is the protocols file. So etc protocols. This will dump the standard out, but we need to send it to a file. So we'll call it protocols.susa2.ldiff. And there are the various supported protocols that are defined in etc protocols. And of course the final step is LDAP add. Let's history grep LDAP add. We'll use what we have here and then indicate the protocols file that we've just created. And there the protocols are being imported. So now we have populated our DIT with items beyond users and passwords. We've got users, groups, hosts, services, and protocols that are all accessible. Now, of course, the NSSwitch conf file must be updated in every case. So etc NSSwitch must be updated. Services, in this case, files LDAP is already there, which means it can consult LDAP in the event of a missing entry from files. And eventually, if you want to centralize on LDAP, which is the point, then just switch these two around, putting LDAP first, then files, although it's generally advisable that you use files over any sort of network-based service. Protocols also will be files LDAP. And just like we've used getEnt for hosts, groups, and users, we may also use it for protocols and services and any other table that's defined. So getEnt hosts returns hosts. Services returns services from both databases. And similarly, protocols will return protocols defined both locally and in LDAP. So we've completed the process of migrating some simple tables from our local files to LDAP. The process generally is straightforward. Sometimes you'll encounter bugs, and you'll have to address them by doing some research, of course, online, in conjunction with some common sense. Now next, we're going to tear down the entire DIT and recreate it to what it should be. So we'll remove all of the OUs and users and groups and hosts and services and everything that we've done thus far and rebuild it from scratch and then continue studying LDAP.